Section 2. Completing the square is useful to help analyze specific features of quadratic functions, such as the maximum or minimum value and the possible number of zeros. When a quadratic equation is written in the form y equals a parentheses x minus 4 to the second power plus k, you can determine whether the function has a max or min value based on a and what the value of k is. This information can also help you determine the number of x-intercepts. Example B has been worked out for us. It says, step 1. Well, first it states, analyze the quadratic function y equals x squared minus 6x plus 13 by completing the square. It asks to complete the square. After it completed the square and moved everything back to y equals form, it has y equals x minus 3 to the second power plus 4. It says, step 2, identify the direction of opening and whether the vertex represents a max or a min. Well, since a is positive, this parabola opens upward and has a minimum value. That minimum value is located at 4, which is the k here. Because it's a minimum, it has a minimum value at 4, and the minimum value is at 4 and it opens upward, that means that it has no zeros. It will not cross the x-axis. And you would verify this by graphing it. Notice that my vertex is at 3, 4, and it never actually touches the x-axis. We're going to dive into some examples of our own. Try these. B, letter A. Write each of the following quadratic functions in the form y equals a, x minus h to the second power plus k. Identify the direction of opening, the vertex, max or min value, and the number of x-intercepts. So we have y equals x squared minus 4x plus 9. So we're going to do y minus 9 equals x squared minus 4x. Off to the side, we're going to do negative 4 divided by 2. That's negative 2. We're going to square that, and that's positive 4. So we're going to add 4 to both sides of the equation. So we add 4, add 4. So this is going to say y minus 5 equals x squared minus 4x plus 4. So we would write this as y minus 5 equals x minus 2 to the second power. That's the perfect square. Now we add 5 to both sides. So y equals x minus 2 to the second power plus 5. So since this is positive, this opens upward. Since it opens upward, that means it has a minimum value. My minimum is at a positive 5. My vertex is 2, the sign, opposite, comma, this, so 2, 5. And because its minimum is at 2, 5, that means it won't actually cross the x-axis. So no x-intercepts. Let's take a look at B. We have y equals negative x squared minus 6x minus 8. First thing I'm going to do is I'm going to factor out that negative. Y equals negative x squared plus 6x plus 8. We're going to subtract 8 from both sides of the equation. So this is going to be y minus 8 equals negative x squared plus 6x. Off to the side, I'm going to do 6 divided by 2 equals 3. And 3 squared equals 9. So we're going to add 9, add 9. So y plus 1 equals negative x squared, plus 6x plus 9. We've got y plus 1 equals negative x plus 3 squared. Now we're going to move our 1 back over, and we're going to subtract it. So y equals negative x plus 3 to the second power minus 1. So what this tells me that negative 1, when we multiply it back over, this is actually going to become a positive 1 because there's already a negative 1 over here. So we're going to actually add this one. So because of the negative here, this is going to open downward. It's going to have a maximum value at positive 1. It's going to have a vertex at negative 3, 1. And because it opens downward and is above, the maximum is above the x-axis, it's going to have 2 x-intercepts. All right, I'm going to have to flip the paper over to do question C. Question C states y equals x squared plus 8x plus 15. So we move our constant first. So y minus 15 equals x squared plus 8x. Off to the side, we're going to do 8 divided by 2 is 4, and 4 squared is 16. So we're going to do add 16, add 16. So this is going to say y plus 1 equals x plus 4 to the second power. We now move our 1 back over. So we got y equals x plus 4 squared minus 1. Since this is positive, it's going to open upward. We have a minimum value at negative 1, because that's my k. My vertex is going to be negative 4, negative 1. And because my minimum value is below the x-axis and it opens upward, we're going to have 2 x-intercepts. There is no debriefing question to follow, so go ahead and write your answers down and make sure you mark this presentation as done.